Hi, this is Dana Gardner, Principal Analyst at Inter Arbor Solutions, and you're listening to BriefingsDirect. While the use of machine learning and artificial intelligence for IT security may not be new, the extent to which data-driven analytics detects and thwarts nefarious activities is still in its infancy. As we've recently discussed here on BriefingsDirect, an expanding universe of interdependent APIs forms a new and complex threat vector that strikes at the heart of digital business. How will ML and AI form the next best security solution for APIs across their dynamic and often uncharted use in myriad apps and services? Stay with us now as we answer that question by exploring how advanced big data analytics forms a powerful and comprehensive means to track, understand, and model safe APIs use. To learn how AI makes APIs secure and more resilient across their life cycles and use ecosystems, please join me now in welcoming our guest. We're here with Ravi Gunter. He's the head of machine learning and artificial intelligence at Traceable AI. Welcome, Ravi.
Thanks, Dana. Happy to be here.
We're glad to have you. So why is API security such a perfect use case for the strengths of machine learning and artificial intelligence? Why do these come together so well?
When you look at the strengths of machine learning, the biggest strengths of machine learning is the ability to process data at scale. And monolithic applications have taken a new avatar, so to speak, which is in the form of API-driven applications. So large pieces of applications have been broken down into smaller pieces, and these smaller pieces are being exposed as smaller applications in themselves. So in order to process the information which is going in between these applications, in order to monitor what activity is going on in these applications, the scale at which you need to deal with them has gone up manyfold. And I think that's the reason why machine learning algorithms would form the best suited class of algorithms to deal with the kind of challenges that we face with API-driven applications.
All right. Well, given the scale and complexity of the app security problem, what makes the older approaches to security wanting? Why don't we just scale up what we already do with security?
So I like to give an example or an analogy as to why older approaches don't work very well. So think of the older approaches as a big box with, let's say, one single door. And for attackers to get into that big box, all they had to do is they had to crack through that single door. Now, what we have done is we have broken that big box into multiple small boxes, and we have given a door to each one of those small boxes. So if an attacker has to now get into the bigger application, the attacker now has to get into each of these smaller doors. And once he gets into one of these smaller boxes, he needs to take a key out of it and use that key to open another box. So what has happened is by creating the API-driven applications, we have actually exposed a bigger attack surface. That's number one. Number two, we have made it challenging to the attackers as well. But the attack surface being bigger now needs to be dealt in a completely different way. The older class of applications looked at rule-based systems as one of the common approaches to solve security use cases. And because you just had one single application and the application would not change that much in terms of the interfaces that it exposed, you could actually build rules in order to analyze how traffic goes in and out of that single application. Now, the moment we broke the application into multiple pieces and we brought in other paradigms of software development, such as DevOps and agile development methodologies, what this has created is it's created a scenario where the applications are rapidly changing. So there is no way rules can catch up with this rapidly changing applications. We need automation in order to understand what is happening with these applications. And we need automation to solve some of these problems, which rules could not do with the older systems.
So we really shouldn't think of AI here as replacing old security or even humans. It's actually doing something that just couldn't be done any other way.
Yeah, absolutely. So there's no substitute for human intelligence, and there's no substitute for the thinking capability of humans. If you go deeper into the AI-based algorithms, you'll realize that these algorithms are really very simple in terms of how the AI is powered. So they're all based out of optimization algorithms. And optimization algorithms really don't have this thinking capability. They don't have creativity, which humans have. So there's no way these algorithms are going to replace human intelligence. They are actually going to work alongside humans. They're going to make all the mundane activities easy for humans and help humans look at the more creative and the difficult aspects of security, which these algorithms can't do out of the box.
And of course, we're also starting to see that the bad guys, the attackers, the hackers, are starting to rely on artificial intelligence and machine learning themselves. So you have to fight fire with fire. And so that's another reason in my thinking that using the heavy tools that you can, the best tools you can, needs to be brought to all sorts of security.
Absolutely.
Another significant security threat are bots, and maybe not just humans, but the scale that the threat vector takes when it comes to use of bots. Is that something that only automation can rely on, or is it the best combination of human and machine to ferret out these bots and other sophisticated means that folks are using?
So usually what we have seen is most of the detection cases that we see in the field of security is a combination of humans and machines. Now, you're very right in the sense the attackers are also starting to use automation in order to get into systems. So we have seen such cases where the same bot comes in from geographically different locations and is trying to do the same thing in some of our customer locations. Now, the reason why they're coming from so many different locations is it basically acts as a challenge to AI-based algorithms. So one older school of algorithms would look at rate anomalies. So they would see how quickly somebody was coming from a particular IP address. Now, the moment you spread the IP address across the globe, you really don't know whether it's different users or it's the same user coming from different locations. So these kinds of challenges have been brought on by attackers by using AI. Now, the only way to challenge that is by building algorithms to counter them. Now, one thing's for sure, algorithms are not perfect. Algorithms do create errors. Algorithms create false positives. And that's where the human analyst comes in to really understand whether what the algorithm discovered is a true positive or it's a false positive. Now, by going deeper into the output of an algorithm, digging back into how exactly the algorithm figured out that something was a bot, is going to give insights into exactly how an attack is being launched. And some of these insights can't be discovered by algorithms. Only humans, when they correlate different pieces of information, they'll be able to find that out. So it's a team, I would say. Algorithms and humans are working together, and that's a team.
And of course, we see the use of machine learning and AI in lots of aspects of IT and security. What makes the way in which traceable AI is doing this different? Why are you unique in your vision for AI, but also in the execution and how you're using it, particularly around APIs?
So when you look at any AI-based implementation, you'll see that there are three basic components. The first component is that about the data itself. It's not enough if you capture a large amount of data. It's not enough if you capture quality data. Most cases, you cannot guarantee data of high quality. There'll always be some noise in data. But more than volume and quality of data, I think what is more important is whether the data that you're capturing is relevant for the particular use case that you're trying to solve. So is the data that you're capturing helpful in solving security use cases? So what Traceable did was it kind of built this platform, which was built ground up to cater to security use cases. So right from the foundations, we started looking at the specific type of data which is required in order to solve modern API-based application security use cases. So that's the first challenge that we address. And I think that the way we built it ground up, I think it's very important. And I think that's what adds strength to the product. Now, once you address the data issue, the next issue is going to be about how are you going to learn? What are the challenges around learning? What kind of algorithms do we use? What is the real scenario when we deploy in a customer location? So we realized that every customer location is going to be completely different. Every customer has completely different set of APIs. The APIs behave completely differently. The data that goes in and out is very different. Even if you take two e-commerce customers, they're doing the same thing. They're basically allowing you to look at products and they're selling you the products. But the way the applications are being built, the API, everything is different. So we realized that it's no use to build supervised approaches. We need to come up with an architecture where the day we deploy it at the customer location, the algorithms self-learn. So the whole concept of being able to learn on its own just by looking at data is the core to the way we build security using the AI algorithms that we have. And finally, when you look at, once you cover the data and the kind of environment in which we need to work, the last step is to look at how exactly are we going to deliver security use cases? What is the philosophy behind building a security product? Now, we realize that rule-based systems are not going to work. So then the alternate system that you have is basically modeled around anomaly detection. Now, anomaly detection is a very old subject, and we have used anomaly detection in various things. We have used it in understanding whether machinery is going to go down. We have used to understand whether the traffic patterns on the road is going to change. We have used the anomaly detection in security. But within anomaly, the class of anomaly detection algorithms, we focused on a class called behavioral anomalies, because we realized that APIs and the people who use the APIs, which are the users, are two key entities in the system, and we need to model the behavior of these two groups. And when we see any deviation from this behavior, that's when we'll be able to capture the notion of an attack. Now, the reason why behavioral anomalies are more important is because a modern attack, if you look at these attacks, you'll be surprised. They're so subtle. You just can't find the difference between the normal usage of an API and an abnormal usage. But buried deep inside the data and buried deep inside how the APIs are interacting, there is a deviation in the behavior. And it's very hard for humans to figure this out. And only algorithms can tease this out and say that this behavior is different from this known behavior. So when you look at it as a stack, we have addressed this at all levels of the stack, at the data capture level, at the choice of how we want to execute our AI, and the choice of how we want to deliver our security use cases. And I think that's what makes it unique and holistic. We didn't just bolt things on, we built it ground up, and that's why I think these three pieces gel well and work together.
I'd like to revisit the concept that you brought up about the contextual use of the algorithms and a multiple number of algorithms being deployed. Because this is sort of a moving target and it's so different use case by use case, company by company, how do you keep up with that change? How do we remain contextual? Is there a way that you perhaps track specific APIs and see a pattern over time? What are some of the more intricate factors in making contextual behavior pattern analysis remain relevant throughout the life cycle of an API?
That's a very good question. So the notion of context is very abstract. So, but when you dig deeper into what exactly context is and how exactly you build context, it boils down to basically finding all, I would say, all factors governing execution of a particular API. So let's take an example. So let's say we have an API and we're looking at how this API is functioning. It's just not enough if you look at what was the input of the API and what was the output of the API. We need to look at something around it. We need to see who triggered that input. Where did that user come from? Was it a residential IP address that the user came in from? Was it a hosted IP address? Which geolocation did the user come in from? Did this user have past anomalies within the system? So we need to bring in all these factors into the notion of context when we're dealing with API security. Now, it's a moving target. So the context, because APIs are constantly changing, data is constantly changing. What is not changing is this context. So the moment when you have fixed this context, when you say that, we know where the users are coming from, we know what the users have done in the past. So there is some amount of determinism that we are adding to whatever detection that we are performing on these APIs. The reality is the inputs to the API, let's say an API takes in 5 inputs and it gives out 10 outputs. So the 5 inputs and the 5 outputs are constant for every user. But the values which go into the input varies from user to user. So your bank account is different from my bank account. So the account number which I put in there is different for you and it's different for me. So if you build an algorithm which looks at anomaly, it'll say, hey, you know what, this particular field, I'm seeing so many different bank account numbers. So there's some problem with this. But that's not true. It is meant to be having large number of variations in that account number. And that comes in from context. So building this context engine is something unique into our AI-based system. And that helps us tease out these false positives and helps us learn the fact that some of these variations that you're seeing are genuine variations. So that's how we keep up with this constant changing environment, where the environment is changing not just because new APIs are coming in, it's also because new data is coming into these APIs.
Is there a way for the algorithms to learn more about what makes the context powerful to avoid false positives that you're finding in your trials and in your initial deployments? Is there certain data and certain ways perhaps that people either use APIs or design the APIs that allows your model to work better?
Yeah, that's a great question. In fact, when we initially started off, we thought APIs are well designed. We thought an API is a small unit of execution. And when developers roll out these APIs, they'll all be focused on very focused piece of execution within these APIs. But soon we realized that developers start bundling various additional features within the same API. We started seeing that they just provide a few more input options. And by triggering those extra input options, you get completely different functionality from the same API. So we had to come up with algorithms which can actually discover the fact that this particular API can behave in multiple ways depending on the inputs that are being transmitted. So we realized that it's difficult for us to figure out that, whether the API is going to change or not going to change. But when we built our algorithms, we assumed that an API is going to have multiple manifestations. And we need to figure out which manifestation is currently being triggered by looking at the data. So we kind of solved it differently by kind of creating multiple personas for the same API. Although it looks like a single API, we have an internal representation which kind of represents this API in multiple personas.
Interesting. Another thing that's fascinating to me about the API security problem is that the way hackers can get in there is to not try to abuse the API, but you have subtle logic abuse attacks where they're basically doing what the API is designed to do, but using it as a tool for their nefarious activities. So how does your model and how does machine learning and the algorithms and modeling that you're doing help fight against these subtle logic abuse attacks?
So when you look at the distributed applications and APIs and the way hackers are getting in using these attacks, which is so subtle, we realize that many of these, we usually classify these kinds of attacks as business logic abuses. So what they're basically doing is they're using the existing business logic, but they are abusing it. Now, figuring out abuse to business logic it's a very difficult task. It actually involves a lot of combinatorial issues that we need to solve. So when I say combinatorial issues, I'm basically meaning that it's a problem of scale in terms of the number of APIs, in terms of the number of parameters that can be passed, and the types of values that can be passed. When we built the platform, we realized that it's just not enough if you look at the calls that are made to the front-facing APIs. We call them the external APIs. It's also important for us to go deeper into the API ecosystem. So we have two classes of APIs. One we call as the external-facing APIs, and other is the internal APIs. So the internal APIs are not called by users sitting outside of the ecosystem. They're called by other APIs within the system. So the only way for us to figure out these subtle logic attacks is to be able to follow the paths taken by those internal APIs. So if those internal APIs are going and reaching a resource, like for example, it reaches a database, and within the database, it reaches a particular row and a particular column and then returns the particular value. Only then you will be able to figure out that there was a subtle attack which took place. And we'll be able to figure this out only because of the ability to trace the data deep into the ecosystem. If we had done everything at the API gateway, if we had done everything at external facing, you would not have figured out that there was an attack which is launched, which went so deep into the system and it touched a resource which it should never have touched. It's all about how well you capture the data and how rich is your data representation in order to capture these kinds of attacks. And once you capture this tons of data which you have, and especially graph kind of data, you have no option but to use algorithms to process it. And that's where we started using graph-based algorithms in order to discover variations in behavior, discover outliers, and discover the patterns of outliers and so on.
It strikes me in listening to you that in order to tackle this problem, you need to know a lot about data and integration, a lot about security and the vulnerabilities, a lot about algorithms and artificial intelligence and data science. Tell me about your background. How is it you're able to sort of keep these big multiple balls in the air at once when it comes to solving this problem? There's so many different disciplines involved.
So it's been a journey for me. When I initially started off way back in 2005, I just graduated from the university and I'd used a lot of mathematical techniques to solve some key problems in natural language processing. But as part of my thesis, I also realized that even security use cases can be modeled as a language. So if you take any operating system, we typically have a few system calls, right? About 200 system calls, or maybe 400 system calls. So all the programs that are running in these operating systems are using these 400 system calls in different ways to build these different applications. So it almost is very similar to natural language. In natural language, you have words and you compose the words according to a grammar in order to get this meaningful sentence. So something similar is happening even in the security world. So that's when we realized that we could apply some techniques from statistical natural language processing into the security use cases. And we were able to discover, way back then, we were able to discover certain Solaris login buffer overflow vulnerabilities. So that's when the journey started. But then I realized that as I went through multiple jobs and working in different kind of use cases, that if you want to be a good data scientist or if you want to use machine learning, you should think of yourself as something like a carpenter, somebody who has a toolbox with lots of tools in it and knows how to use those tools very well. But in order to use those tools, you actually need to build various things. You need to build a chair, you need to build a table, you need to build a cart, you need to build a house. So you need to build various things using the same set of tools. And that took me through a journey. So I started with natural language processing, then I went to image processing, then I went into video processing, and then came into security. And so it was a journey. And through the process, what happened was we started to realize that almost all problems can be mapped to a canonical form. You could take any complex problem and break it down into some simple problems. And almost all fields can be broken down into these simple mathematical problems. And if you know how to use those mathematical concepts, you'll be able to solve a lot of different problems. And I think we are kind of applying the same principle at Traceable as well. So yeah, it's been a journey. And every time you look at data, you come up with different challenges. And the only way to overcome that is to kind of dirty your hands and kind of solve it. And I think that's the only way you would learn. And that's the only way we could build these new class of algorithms by taking a piece from here, a piece from there, putting it together, and then building something else.
That's fascinating. And to your point, so many difficult things in nature and in business and in technology can be brought down to an elemental mathematical understanding. When you've attained that with these APIs, for example, in business services and data, we're applying this first to security, and rightfully so. It's an essential problem, the low-lying fruit, if you will. But over time, it seems to me that you'll also get mathematical insights and understanding of more about how microservices are used, or how they could be optimized, or architectures could be optimized, or how the relationship between developers and the production crew might be optimized. So is that what you're setting the stage for here, is a mathematical foundation that can be brought to a much greater and potentially productive set of problem solving?
So if you've been thinking about it, and we have kind of started on the journey already. So when we look at what we have achieved as of today, and we look at the foundations over which we have built, we see that we have something for everybody. We have something for the security folk. We have something for the developer folk. And we have realized that the system that we have built kind of gives insights to developers as to what happens to their APIs when they're in production. Usually the development team just doesn't know what happens to their APIs when it's in production. How is it behaving in production? How many users are using these APIs? How are they using it? They have no clue as to what's happening there. And on the other side, the security team doesn't know exactly what this application is. They can see lots of APIs, but how are these APIs all glued together to form this big application? Now, the mathematical foundation under which all these implementations are being done is based on relationships between APIs. You can call them graphs, you can call them sequences, but it's all about relationship. Now, one aspect which we are looking at is how do you expose this relationship? We are today having this relationship buried deep inside our implementations and inside our platform. But how do you take it out and make it visual so that they understand what happens? What is this application? What happened to our APIs? Now, by looking at some of these things in visual form, you'll be able to figure out various things like, are there bottlenecks within our application? Is this one API constantly hit in order to, if you want to complete let's say my card checkout, I always go through this API, but the same API is also leading me to the search engine. It's also leading me to, let's say, my products catalog page. So why is it this API needs to go through all of these? So can I simplify that API? Can I break it down and make it multiple pieces? So this kind of insight is being made available to the developer community.
For those that are listening or reading this interview, how should they prepare themselves for being better able to leverage and take advantage of what Traceable AI is providing? And that would be for both the developers as well as the security, as well as the operators. What should they be thinking or doing now in order to be in the best position to leverage what you all are producing?
So the moment you deploy Traceable in your environment, the algorithms kind of start kicking in and they start learning about the patterns of traffic in your environment. So within a few hours, if your traffic has a high volume, or within 48 hours, if you have low volume traffic, you'll get an insight as to the API landscape within your environment. You'll get to know how many APIs are there. That's, I think, one of the fundamental problems that a lot of companies are facing today. They just don't know how many APIs are there. Once you know how many APIs are there, you get to figure out how many services are there. What are these different services? Which API belongs to which service? So it gives you an entire landscape within a few hours of deployment. So once you understand your landscape, the next interesting thing that you'll see in our user interfaces and all of that is how risky are our APIs? So are we exposing sensitive data? How many of the APIs are external facing? have we used authentication in order to give access to our APIs or not? And why some APIs do not have authentication? How are we exposing APIs without authentication? So all these questions are answered right there in the user interface. So just have to eyeball and just see, and you get to figure all these things out. Once you have done these pieces, you can also look at whether your development team, the spec which the development team said complies with whether the APIs comply with that particular spec is true or not. Because usually what happens is the development teams are rapidly churning out code. They never maintain the API spec. So they will have a draft spec and they will build against it. But finally, when you deploy it, the spec looks very different. But who knows it's different? How do you know it's different? So the insight as to whether your spec is compliant or not, you get to see right there the moment you deploy within a few hours of your deployment. So in addition to knowing what happened to your APIs and whether they are compliant with the spec or not, you'll start seeing various behaviors. Usually people think that when you have, let's say you have about 100 APIs which are deployed, all users use the APIs the same way. So suppose I have a mobile app, my banking app. And when I log into my banking app, there's a few APIs which I call unconsciously, right? I don't know, I'm just pressing buttons. So we think all of them use the app the same way. But in reality, you'll be surprised to see that users use these apps in so many different ways. Sometimes the APIs are accessed through computational means. Sometimes they're accessed through user interfaces. So there is insight to the development team in terms of how users are using your APIs, which itself is a great insight, which will help you build better APIs, which will help you build a better application by simplifying your application deployments. So all these are available to you within a few hours of deployment. And I think that's what is very exciting. So when you just deploy it and then open the screen and look at all the information which is out there, it's just fascinating to see how different companies have built their ecosystems. And of course, you have the security use cases. You can start seeing bots at work. So we have seen, how does the Bing bot from Microsoft look like? How active is it? Is it coming from 100 different IP addresses, or it is always coming from one particular geolocation? So you can see how, let's say, a search engine spider is looking like. What's it doing with our APIs? Why is the search engine starting to look at these APIs, which are internal and which has no information, but why is it crawling these APIs? So all this kind of information is available to you within a few hours, and it's really fascinating when you just deploy.
And it's interesting that you can just start there, but there's, as we discussed earlier in our interview, so many other powerful and automating and learning capabilities that will come to bear in the future on some more sophisticated issues around security. Well, I'm afraid we'll have to leave it there. You've been listening to a sponsored BriefingsDirect discussion on how data-driven behavioral analytics best detects and thwarts nefarious activities from across the burgeoning use of APIs. And we've learned how advanced machine learning, powered modeling, and algorithms form a powerful and inclusive means to track, understand, and model APIs use in action. And so a big thank you to our guest. We've been here with Ruvi Guntur. He's head of machine learning and artificial intelligence at Traceable AI. Thank you so much.
Thanks, Dana.
And a big thank you as well to our audience for joining this BriefingsDirect API resiliency discussion. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host throughout this series of Traceable AI sponsored BriefingsDirect interviews. Thanks again for listening. Please pass this along to your business community and do come back next time.